Hi class. We're now going to take a look at what can happen to solar radiation as it passes through the Earth's atmosphere. And so this figure that I'm going to draw is going to be really, really important. Okay. Now I probably say that about every figure that I draw. And if I don't say it, I think it. But this one really, really is important. Okay. We are going to be building on this figure throughout the entire semester. Okay, so this is your first introduction to this, and it's the three fates or the three things that can happen to solar radiation as it passes through the Earth's atmosphere. Okay, so let's draw first. Here we have the sun, and the sun is emitting its energy through space, and some of it is being intercepted by the Earth. Okay, so we've got solar radiation passing through space, reaching the top of the Earth's atmosphere. And so the first thing we can do is remind ourselves, what is this solar radiation made up of? Okay, and so approximately 7% of that is ultraviolet radiation. Approximately 43% is visible radiation, and approximately 49% of that energy is infrared radiation. Okay, all the others, gamma rays, X-rays, microwaves, and radio waves make up about 1%. And again, we're not going to worry about that 1% in this class. We're going to focus on these three forms of radiation. Okay, so we've got solar radiation passing in wave form, because that's how radiation travels, in wave form, through space, reaching the top of the Earth's atmosphere, and now it's going to start to penetrate through the Earth's atmosphere. Okay, so here we go. And so it's not the first thing that can happen to it, but one of the things that can happen to it is that solar radiation can be reflected. Okay, and so we have to ask ourselves, what gets reflected? Well, we've got three choices here. Is ultraviolet radiation reflected? Is visible radiation reflected? Is infrared radiation reflected? Is it all three? It turns out that it is visible radiation that gets reflected. Okay? And that kind of makes sense, because if you get up in the morning and you look in the mirror, what allows you to see your reflection, that's visible radiation that's being reflected, that allows you to see your reflection in the mirror. Okay? And so in the atmosphere, in the Earth atmosphere system, what is doing that reflection? Okay? And so fresh snow, well, all snow, but particularly fresh snow, is a very good reflector of solar radiation. And you know that, because if you've ever gone skiing or you've gone out the day after a snowstorm and the sun is out, you know how blinding that snow can be, the reflection of visible solar radiation off of that snow surface. And if you go skiing, you almost always have to wear sunglasses if you're skiing during the day. Another just as important element in terms of reflection of visible solar radiation are clouds. And actually, clouds are probably even more important, because clouds make up a larger surface area to be reflected off of. So snow, as you know, is kind of going to be limited to the polar regions, whereas clouds can be all over the Earth's surface. And so clouds are a huge reflector of incoming solar radiation. Okay? And how much on a global basis? We often talk globally in this class. On a global basis, about 24% of incoming solar radiation gets reflected. Okay? What else can happen to that incoming solar radiation? So as we continue, again, this is not the second thing that can happen to it. It's just another thing that can happen to it. I just happened to put it second. Okay, but another thing that can happen to it is that solar radiation can be scattered. Okay, and when we talk about scattering, it hits a molecule, it hits an impurity in the atmosphere, and whatever it hits is going to scatter it off in all different directions. Okay? And so again, we have to look at, so what's being scattered? Ultraviolet, visible, infrared. It turns out that again, this is visible radiation that gets scattered. Okay, there will be some ultraviolet, but mainly it's visible radiation. And this is really kind of cool. So how, what is out there that does most of the scattering? It turns out that the oxygen and the nitrogen in our atmosphere, which makes up 99% of the atmosphere, these two molecules love to scatter shorter wavelengths of visible radiation. So remember that when we look on the range of visible radiation, what are the colors that are on the shorter range in terms of wavelength of visible radiation? The shorter ones are the blues, okay? And so as a result, because oxygen and nitrogen like to scatter the shorter wavelengths of visible radiation, this explains why our sky is blue. And it's actually called Rayleigh scattering because a scientist way back in the day by the name of Rayleigh discovered this scattering of shorter wavelengths and thus a blue sky. Okay, there is something else in our atmosphere: water vapor and water droplets. So water vapor and droplets. They're not very particular about what they scatter. So water vapor, water droplets scatter all wavelengths equally. GTH, there we go. All wavelengths equally. Okay. So whether it is the wavelengths of blue visible radiation or green visible radiation, yellow, orange, red, it doesn't matter. It scatters all wavelengths equally well. Okay, and as you know, when you put all the colors together, you get white light. Okay, so as a result of water vapor and water droplets scattering all wavelengths of visible radiation equally, okay, you end up with white clouds. So thus, clouds are white. So if you ever wondered why are clouds white, now you know. It's the scattering of all wavelengths of visible radiation by water vapor and water droplets that make a white cloud. Okay? So that's another thing that can happen to visible radiation is it can be scattered. Okay. Another thing that can happen to solar radiation as it passes through the atmosphere, so this is the third one, is that solar radiation can be absorbed. Oh, I'm sorry, I forgot one thing here with scattering. Okay, how much of the incoming solar radiation is scattered? About 7%. Okay, and so when you put reflection and scattering together, that's 31%. It's almost 1/3 of the incoming solar radiation is either reflected or scattered. Okay, so a third thing that can happen to solar radiation as it passes through the Earth's atmosphere is that it can be absorbed. Okay, so absorption of incoming solar radiation. All right, so again, we have to look at what's being absorbed. In this particular case, it is primarily ultraviolet radiation and infrared radiation that's being absorbed. Okay, so what is absorbing ultraviolet radiation? So atomic oxygen and ozone will absorb ultraviolet radiation. Okay, so remember we talked about ozone in the stratosphere, oxygen in the thermosphere absorb ultraviolet radiation as solar radiation passes through the Earth's atmosphere. Okay? And that's why temperatures increase with height in the stratosphere, thanks to ozone, and in the thermosphere, thanks to oxygen. Okay? And as we continue in the thought of absorption, water vapor, humidity, okay, and to a much lesser extent, carbon dioxide, primarily water vapor in this case, so I'll underline that one. Okay, water vapor and some carbon dioxide will absorb infrared radiation. Okay. All right. How much of the sun's energy as it passes through the Earth's atmosphere is absorbed? About 20%, which is really, think about it, that's not too great a number. And we'll talk about that in the next section. Okay. So the three fates, what three things can happen to solar radiation as it passes through the Earth's atmosphere? It can be reflected, it can be scattered, it could be absorbed. And again, when you put these three things together, so reflected is 24%, okay, plus scattered is 7%, plus absorbed is 20%. Okay, put those three together. On a global basis, this is 51%. Okay, so on a global basis, about half of the incoming solar radiation never makes it to the Earth's surface. Okay? About half of it never makes it to the Earth's surface because it's reflected, scattered, and absorbed. Okay? But what does happen to it if it's not reflected, scattered, or absorbed as it passes through the Earth's atmosphere? It gets absorbed by the surface. Okay. How much gets absorbed? Well, that's the other 49%. So again, only about half of the incoming solar radiation that passes through the Earth's atmosphere actually makes it down to the surface to be absorbed. Okay? And remember what we said about absorbed solar radiation. Any object, the Earth's surface, that absorbs any form of radiation, ultraviolet, visible, infrared, will warm up. Okay? Whenever any object absorbs any form of radiation, the object is going to warm up. In this case, the object is the Earth's surface. And so this energy that's being absorbed, solar radiation absorbed by the surface, this is going to be converted to heat energy. and it's going to be in the form of infrared radiation. Okay? And it's important to keep in mind that the Earth's surface only emits infrared radiation. Okay, so when you think about it, that's, and not a lot of people do. Not a lot of people are weird like me. But based on the temperature of the Earth's surface only emits infrared radiation. So whenever you're out in the woods, away from city lights, okay, and there's no moon, maybe it's a new moon, it is completely dark out there. Why is it completely dark? Because the Earth only emits infrared radiation. It does not emit visible radiation. Okay, the moon is the same thing. The moon only emits infrared radiation. Okay, we're able to see the moon only when the sun's visible radiation is reflected off of the moon's surface. That's what makes the moon visible to us, is reflected solar radiation, the moon reflecting the sun's visible radiation. Okay, so again, this is a really important figure. Do your best to understand it, and actually, in some cases, you know how I don't like memorization, but really, in this case, you probably really do need to memorize this figure. Understand it, but also memorize it. Okay, alrighty. On to the next section. We're going to talk about the greenhouse effect next.